कहाँ से लिए आपने ये क्वेश्चन? ओके ओके, so let us revise GOC by these questions. Okay, ozonolysis, that okay, so we have questions from GOC and hydrocarbon. So first question is the number of CH2 means methylene groups in the product formed from the following reaction sequence. First, we have a compound that is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it is oct 1, 2, 3, 4. Oct 4 in so we have oct 4 in. So when this oct 4 in or any alkene, when it is treated with ozone and then followed by zinc H2O means reductive ozonolysis. This is O3, this part, first one, O3 with Zn H2O. This is called reductive ozonolysis. And it is given in NCERT, hydrocarbon part, class 11. So whenever we have alkene and this alkene undergoes ozonolysis, so first ozone is added and we get ozonide, and this ozonide when treated with ZnH2O, there is a breaking of carbon-carbon double bond and ultimately we get 2 molecules of carbonyl compound and removal of ZnO. Okay, so now when we have this particular alkene, so what is happening actually? There is a breaking of carbon-carbon double bond. Simple. If you don't want to expand this reaction in this way, you just do one thing, just break carbon-carbon double bond and instead of double bond, just attach oxygen. So now come to the alkene that we have. So just we break it from here and we attach double bond on both sides. So see, it is symmetrical alkene, I think. See, 1, 2, 3, 4. 1, 2, 3, 4. That means at the end of the 4 carbon atom chain, there is C double bond O group. That means we get 2 molecules of CH3, CH2, yes, CH double bond O, right? Because we have this alkene so in this alkene, when ozonolysis takes place, there is a breaking of carbon-carbon double bond and instead of carbon-carbon double bond, we get carbon-oxygen double bond. So there we get two molecules of butanol. So that means first step of this reaction that will give us 2 moles of butanol. Now, this butanol is treated with KMnO4. So you know when KMnO4 react with aldehyde, KMnO4, what is the nature of KMnO4? It is an oxidizing agent. So as it is an oxidizing agent, it will oxidize the aldehyde into carboxylic acid. So we get carboxylic acid. There should be something with it. It is just, it means it is an indication that KMnO4 is used. Okay, so just write, you can write it as C, because in KMnO4 nothing is given, so you can take it as COOK. Right, potassium salt of carboxylic acid, and then on acidification we get carboxylic acid. So it is potassium butanoate So in the second step, we get potassium butanoate. First is butanol and then potassium butanoate. This is in the second step. Okay. Now come to the third step. Third step is sodium hydroxide and electrolysis. So we have potassium salt of carboxylic acid and then we treat it with sodium hydroxide and do the electrolysis. So do you know what is the name of this reaction? Yes, beta. Beta is simply coal-based electrolysis. Okay. So see, whenever we have electrolysis, there is only one reaction, I think, that will electrolyze in the presence of sodium hydroxide. We have sodium or potassium salt and then treatment with KOH or NaOH and electrolysis. So we have CH3, CH2, CH2, COO negative, K positive. So whenever electrolysis takes place, what is the nature of the reaction? Yes. Just keep in mind this thing, helper. If there is high temperature, there is presence of electricity, light, peroxide, electrolysis, radical initiator, then there is a free radical reaction. So that means now in this case, first of all, there is the removal of electron. So we get CH3, CH2, CH2, COO. This free radical we will get. And in this case, we get two molecules, two, again two, and this reaction takes place at anode or cathode? At anode, beta, because there is removal of electron. Yes, this reaction takes place at anode. So there is a removal of two molecules of carbon dioxide. Now these two free radicals combine together, and ultimately we get normal hexane as the product, right? So normal hexane is formed at anode along with carbon dioxide. This is reaction at anode, and this is the mechanism of coal-based electrolysis given in NCERT. Then at cathode, there is a competition between we have NaOH and because electrolysis means this is aqueous solution, obviously. So there is a competition between Na plus, K plus, and H2O. So obviously, when Na plus, K plus, and H2O is there is an electrolysis of water. So we get hydrogen gas along with OH negative. So ultimately we will get normal hexane as the product. Now this normal hexane, when it is treated with Cr2O3 or Al2O3 or Mn2, there are few reagents when this reaction takes place at 770 Kelvin and 20 atmosphere pressure, there is cyclization followed by aromatization. So this normal hexane leads to the formation Cr2O3 at 770 Kelvin, 20 atmosphere pressure, that will lead to the formation of a benzene. It is also, this reaction is also given in NCERT. So this, I hope this question should be from JEE Advanced, is it?
Yes, sir.
So see, question is from JEE Advanced, but it is very well from NCERT. If you connect the dots, you will get the answer. Okay, so come to the next question. Next. Okay, major product formed in the following reaction is. First, there is a trip. Oh, okay, question is different, right? Number of CH2 group in the product is 0. Because at the end of the reaction, after these 4 steps, we will get benzene and there is no CH2 group in it. Okay, so next is major product formed in the following reaction is. So we have one terminal alkene, alkyne, and another one is non-terminal alkyne. So it is treated with sodamide followed by sodium in liquid ammonia. What is the name of this reaction? This is Birch reduction. Actually, there are 2 reagents. One is H2PD, that will give cis alkene, and sodium in liquid ammonia will give trans alkene because there is anti-addition of hydrogens. So that means first look at this alkyne. So when this alkyne will undergo reduction, that will give trans alkene. So let us see. In first case, there is a trans alkene. In second case, this is, if you see, it is like this. It is a trans alkene. So means in case of A, B, in both cases we get trans alkene. Here we have cis alkene. Again we have cis. That means C and D are not the right answers. Okay. So we left with 2 options. But you know, these alkynes are isolated, and both the alkyne groups, because it is not written as one equivalent or anything. That means we can use any amount. So both the triple bonds are reduced to alkene. Yes, double bond. So that means A is the right option. Okay. In the reaction given below, total number of atoms having sp2 hybridization in the major product. Okay. First is ozone in excess and then zinc H2O, already we have done ozonolysis. This ozone will attack at the double bond. So there is a breaking of double bonds. This is the reactant. Now, when ozonolysis takes place, there is a breaking of double bonds, and when these double bonds break, there is a formation of a double bond O. Now, when we have carbonyl group and is treated with NH2OH, that is hydroxylamine. So there is a removal of H2O. This is from aldehyde ketone carboxylic acid. Addition of ammonia derivative. So we get this product. So obviously from this particular so this double bond becomes double bond NOH, double bond NOH, double bond NOH, double bond NOH. So that will not affect second. Hybridization remains same. So there are in total 4 atoms, 4 carbon atoms having sp2 hybridization. 4 carbon atoms. And what about this nitrogen? This is also sp2 because there is a lone pair. So they are also sp2 hybridized. So in this way, in total, we get 4 plus 4, 8 number of atoms. Right? Total number of hydroxyl groups present in a molecule of the major product P is. So see H2PD barium sulfate quinoline. What they do? Yes, it is partial reduction. Means alkyne is converted into alkene with cis structure. Means जैसे Birch reduction में we get trans product. In this is called Lindlar's reagent or catalyst, and that will lead to the formation of cis alkene.
So we also use this in Rosenberg reduction, right?
Yes, same. Yes. In both, in here we can use H2PD oblique carbon. In both the cases, in that case Cl is replaced by H. We get aldehyde, and here alkyne is converted into alkene, but cis alkene.
Yes.
So ultimately, this part remains as such because there is only one double bond, and double bond is not affected by, if it is H2PD, then all the double bonds and triple bonds are reduced and we get sp3 hybridized carbon. Hydrogen is added, but because of barium sulfate and quinoline, that will not be affected. Double bond is not affected. Only triple bond. So one, this is, and now it is now double bond. 1, 2, this is double bond. It should be like this. Got it? Double bond should be in cis geometry. Now we treat it with dilute KMnO4, and that is at 273 Kelvin. That means there is hydroxylation reaction. There is hydroxylation reaction, means these double bonds are replaced. Yes, double bonds are replaced by OH. So this is, here there is a double bond, so that is replaced by OH. Again double bond replaced by OH, and here it is syn addition. That is also important in stereochemistry, but I think yes, there is syn addition. Keep in mind, KMnO4 shows syn addition of OH groups. How do it goes? See, in this way, there is a double bond. KMnO4, you know, in KMnO4 it is K plus and MnO4 negative, and MnO4 negative is tetrahedral. Actually, when KMnO4 is treated with it, it is like this. This type of product is formed and then followed by hydrolysis. It is like this, plus MnO2. So this is the syn addition, means OH groups are attached on the same side of the double bond. So total question is not stereochemical aspect. It is simple question that how many hydroxyl groups present in the molecule. So 2 plus 2 plus 2 is total 6. Okay. So see, this is syn addition. This one is also syn addition. Lindlar's catalyst has syn addition of hydrogen atoms. Syn addition of hydrogen atoms, and dilute KMnO4 has syn addition of OH groups, hydroxylation.
Yes, sir.
Oh, sorry. Next, we have 4 molecules. In first case, it is aniline, and you know lone pair is in conjugation with pi bond ring.
Yes.
So lone pair is involved in conjugation. Here it has lone pair, but at the same time it has SIR effect. What is SIR? It means steric. Yes, steric inhibition to resonance. So actually aniline is a weak base due to the presence of resonance conjugation. So this resonance is somewhat inhibited due to the bulky alkyl groups, and at the same time they will provide electrons to the nitrogen. So electron density on the nitrogen is increasing, means they provide synergic effect. Reason being, two methyl groups provide electrons to the nitrogen, so electron density on the nitrogen increases, and at the same time they will not allow nitrogen to donate electrons to ring due to inhibition, due to SIR effect. And that's why if you compare 1 and 2, 2 should be more basic than 1. Right? Now let us compare third and fourth. In third and fourth, both have nitro groups. And that is at ortho and para position, where they have means effect. Yes. So NO2 will withdraw electrons from NH2 strongly. So electron density on the nitrogen decreases. So third should be least basic. Now when we come to fourth one, first of all there is SIR effect. At the same time these NO2 are at the ortho to this inhibition, so they will show less resonance because they go out of plane due to hindrance. So withdrawing effect becomes less. So fourth is more basic than 3.
But both are less basic than 1 and 2.
Yes. Fourth is more basic than third, but both are less basic than second and first. So this should be the order of a. So that means A is the wrong option. Now come to the second. The magnitude of pKa difference between 1 and 2 is more than that between 3 and 4. Means difference in basic strength, we can say, in between 1 and 2.
Should be similar, no?
Actually, nitro group, what they do, they decrease the electron density to large extent. So third and fourth, they have negligible basic strength.
Okay.
So difference between 1 and 2 is more, because in first case there is free resonance, means there is no hindrance at all. But in second case, due to the presence of methyl groups, SIR effect, so that's why second is the basic strength difference between second and first should be greater. But at third and fourth, it is already very less. So even SIR effect will not enhance its basicity to much large extent, because it is asking about difference. So difference between first and B color. Magnitude of pKa difference between 1 and 2. ज़्यादा होना चाहिए. Yes. Okay, so let us discuss third one. Resonance effect is more in third than in fourth. It's true, because in fourth case, due to this SIR effect, resonance will decrease. Okay. So there is no resonance at this point, no resonance at these ortho positions. Got it?
Yes.
They have only minus I effect, because resonance is eliminated. Right. That's why it is written like that, because here resonance is diminished to large extent. Okay, there is steric hindrance from ortho positions as well. In second case, there is a effect from 2 methyl groups, that is on nitrogen only. But in case of fourth, even nitro group will increase so SIR effect is maximum in fourth. Right? That's why it is written that difference between third and fourth is more than in first and second. C is right. Now, steric effect makes compound 4 more basic than third. That's true.
Yes.
So C and D is correct. Okay, there is more SIR effect actually.
Yes.
First on the nitrogen due to these methyl groups, and on the benzene ring due to ortho positions of nitro groups. Okay. Next, choose the correct options that gives an aromatic compound as the major product. Aromatic. Okay. So first is Cl2 in excess in the presence of UV light. So what will we get? We get all the positions are occupied by chlorine, because it is free radical reaction now. Yes, it is also given in NCRT, this reaction. In hydrocarbon chapter, I think alkane wale part में दिया होगा. It is C6H6Cl6. It is also called 666 or lindane. Benzene hexachloride. This is called benzene hexachloride. Though it is not aromatic, but its name is benzene hexachloride. So that means it is not it will not give aromatic compound. Now second one, I have already told you that alcoholic KOH will remove first HBr. There is dehydrohallucination, but if NaNH2 is present, that will remove even vinylic halide. So above all, first there is removal of HBr. Again, in the second step, there is removal of HBr. And ultimately, we get from first and second step. In first step, there is double bond. And then in the second step, we get triple bond. So we get propyne from first and second step, right?
Yes.
Now, after getting this propyne, there is red hot iron tube. This reaction is also given in NCERT. Yes, 3 moles. 3 moles of these molecules at 873 Kelvin. In our syllabus, it is, I think, given as ethine. Acetylene, 3 molecules of acetylene in the presence of red hot iron tube will give benzene. It is like this. Now, here instead of ethine, we have propyne.
Okay, so we'll get 1,3,5 trimethyl benzene.
Yes, we get 1, then 3, 5 benzene. So that means the second will give us aromatic compound. Now come to third. In third case, we have,
This was Williamson synthesis.
yes, it is Williamson ether synthesis, but instead of primary aliphatic halide, we should have primary halide, right?
Yes.
But here we have secondary, so we should get 2 products.
Okay.
So first product is this one along with NABR, and second product should be this one, alkene, but this is highly unstable
Yes.
because it is anti-aromatic, so this product cannot be formed. So if product is formed, that is this one only, and it is not aromatic.
Yes.
So third is not the right option. Now fourth one, we have sodium methoxide, which is a base, just like sodium hydroxide. Now, to act as a base, this compound should act as an acid. So if it will give H plus, we get this compound, cyclopentadienyl, and it is aromatic.
Yes.
So obviously this will be formed,
Yes.
and we have this one as aromatic as well.
Yes.
So 2 plus 2 plus 2. So 6 pi electrons, and this is the aromatic ring. So second correct options which gives the aromatic compound as the major product are 2 and 4. Okay, so this is the among the following the number of aromatic compounds. First one is it is non-aromatic. Though it has 8 pi electrons, but I have already told you that this compound has tub shaped structure, which is non-planar, and because of its non-planarity, because anti-aromatic compound should be planar. Anti-aromatic, there is only one difference from the aromatic. Other things are same. Cyclic, planar, conjugated pi electrons, and number of pi electrons in aromatic are 4n plus 2. Here they are 4n pi. So that 4n pi rule is followed by this cycloocta tetraene. But it has tub shaped structure. Keep in mind. That's why it is non-aromatic compound. Okay. Second one. It is anti-aromatic because now it has 4 pi electrons. This one aromatic. What about this? Non-aromatic because there are carbons with, yes, this one, yes, this is called tropylium cation. What about this? Anti-aromatic. Here, this is also already we have done just now. So it is aromatic. And what about this? Non-aromatic. Very good, because there are 2 sp3 hybridized carbons. What about this? This is aromatic because all the rings are in conjugation. Total pi electrons are 14. Okay. No, phenanthracene. Actually, anthracene is like this. All the rings are in the linear fashion. Right? So this is called phenanthracene. This is anthracene. Okay. So in this way we get 1, 2, 3, 4. So there are 4 aromatic compounds. Okay. Major product obtained in the following conversion is. So see, we have, yes beta. One equivalent of Br2. So it is mentioned only one molecule of bromine reacts. So say we have how many functional groups? First, it is aromatic. We have benzene ring. We have, where is ether? This is ester. We have ester group. We have alpha, beta, unsaturated ketone. So these are the functional groups we have. Now bromine, so bromine will attack obviously it will attack at the alkene, because alkene is most reactive part where bromine can attack. So we will have ester remains as such,
Yes.
this keto part, and this is cyclic bromonium ion. I hope you know it. Yes, this is the carbocation form. It means sorry, it is not carbocation, it is cyclic bromonium ion. There is a formation of cyclic bromonium ion because when bromine is added in any molecule, there is anti-addition of bromine atoms.
Yes.
See, if we have double bond, this is cis alkene.
Yes.
I will draw it vertically. This is cis alkene, right? So cis alkene, when bromine is treated with it, it leads to the formation of cyclic bromonium ion. Means when this Br2 approach, because Br2 is non-polar, so when Br2 approach it, you know, the one bromine which is closer to the pi bond system, that get positive charge and other one will get negative charge.
Hydrolytic fission.
Yes, and then this Br is added to it
Yes.
because this part is electron rich, you know, pi electron cloud.
Yes.
So pi electron cloud will repel the electrons and therefore make bromine polarized, and therefore the bromine closer to the pi bond system, means closer to the electron cloud, get positive charge, and which is bromine which is away from the cloud, that will get negative charge. So in this way bromine negative is removed and Br positive is added. Now when this bromine negative left after cleavage, now when Br negative will attack on it, you know, it will attack from the side which is opposite to the side where Br positive is added, because this side is already blocked by this ion,
Yes.
and therefore Br negative ion will attack from opposite side, and that's why it is called anti-addition. So due to this anti-addition, it should be, if it is H, Br, it is Br, H.
That's it.
So Br, H, H, Br, CH3. So we get racemic mixture. So you should keep in mind car. Car means cis alkene. Anti-addition. A for anti-addition, and that will give R, that is racemic mixture. What is other one? If there is, first we keep in mind car, if it is racemic, and other one is meso.
Yes. Maybe.
So let us say we have transalkene. Again, addition of bromine, the same way we get cyclic bromonium ion, attack of Br negative from opposite side. Sorry. And such a compound has no mirror image because it has plane of symmetry,
Yes.
and it is called meso compound. Okay. So CAR CSM TAM TSR. So see, cis anti-racemic, if we replace cis anti by cis sin, sorry, sin means same side, so we get meso.
Yes.
See, it is anti. We replace cis by trans, so R becomes M. Okay, cis to trans, sin, so meso becomes racemic. So, anyhow, in this case, stereochemistry is not asked. Simple, after formation of this cyclic bromonium ion, we have methanol and Br negative. So this methanol, because there is only one equivalent of bromine. So when this bromine is attached on the other side, methanol will attack, because methanol, this H plus ion is taken by Br negative, we get HBr and methoxide ion. So this methanol will attack on one side, and therefore, see, when this methanol attack, we have either one, see, methanol and, sorry, so now question is that bromine is attached to CO side or on the other side. So tell me, methanol will attack on this carbon or other one? लोन पेयर कहाँ पे अटैक करेगा बताओ, इस साइड या इस साइड?
upper side, sir.
Why?
Because okay, electron density is low, sir, right?
Yes, yes, because you know there is a CO group which is electron withdrawing group,
Yes.
so it withdraw electron density, and therefore methanol will attack on the side closer to CO. So ultimately this part will not be affected, remains as such. That is in all the cases. This CO remains as such. So methanol will attack on this side. Okay. So ultimately we get second as the major product. Okay. We get first one to small extent, but this one is the major product. Okay. Major product of the following reaction. First is HCl, and in the presence of AlCl3 anhydrous. It is just like Fiddlecraft reaction.
Yes, sir.
See, we have H positive Cl negative, anhydrous AlCl3. So ultimately we get H plus and AlCl4 negative. So this H plus ion will attack. Where it will attack?
It will attack on double bonds, sir, on
Y-
the left side.
Yes, it will attack on the double bond, and we get secondary carbocation.
Yes.
So now next step is electrophilic substitution reaction. We get electrophile, this behaves as electrophile.
Yes.
Now what is the nature of OH? It has plus R effect and orthopara directing.
Yes.
So electrophile will either attack at ortho positions with respect to OH or at a para position.
Yes.
So obviously it will attack at para position here and leads to the cyclization.
What is the problem with ortho, sir?
Okay, because this ortho position is वैसे भी para जो है that makes it means it is more at para rather than at ortho, and at the same time this position is far away from this carbocation because it is attached at one end. This is approachable position, but this is not, this electrophile will not attack here. Reason is simple, that OH is closer to it and carbocation will attack at the position where electron density is more. So obviously para is preferable position. वैसे भी देखा होगा ना, para is the major product rather than ortho. So that's why it give one 2, 3 means 1, 2, 3. So this is the product formed. So fourth one is the right option. Next. These are from IAT.
This one is KVP.
KVPY, okay. In the following set of aromatic compounds, nitrobenzene, benzene, methyl benzoate, methoxybenzene, the correct order of reactivity towards Friedel-Crafts alkylation means towards electrophilic substitution reaction. Aromatic electrophilic substitution reaction. So obviously, you know, electron releasing groups increases reactivity because they will increase the electron density on the ring, and electron withdrawing groups decreases the reactivity because they will decrease the electron density at the ring. They are activating groups, and withdrawing groups are deactivating groups. Means groups having plus R effect are activating, groups having minus R effect are deactivating. So NO2, what is the nature of NO2?
NO2 is minus R.
Minus R as well as minus I.
Minus I.
No effect.
Yes, sir.
What is the effect of COOCH3?
Minus R. Minus R.
Minus R, because it is C double bond OOCH3, right? So whenever we have a pi bond attached directly to the atom which is attached to a ring has minus R effect. So it has minus R effect, and at the same time minus I. What about this?
This is plus R and minus I.
Plus R and minus I. Oxygen being more electronegative than carbon, so minus I, and it has a lone pair, that's why plus R. So this one is electron releasing. Electron withdrawing. Electron withdrawing, no effect. So in first instance, we can see that fourth should be more reactive than second. Then it is first and third. Out of first and third, which one is more electron withdrawing? Yes, NO2 is more electron withdrawing, so it deactivates the ring to large extent. That's why first is least reactive. So it should be in this order: fourth, second, third, first. Oh, by mistake, options are not given. It should be fourth. Second is missing.
Okay.
I think by mistake it is happening. It should be fourth, second, third one. Okay, third, first. Right? Okay. Among the following substituents, pyridines, the most basic compound is? I think it is the most simple question. Reason being, all are pyridines. So as all are pyridines,
They will readily donate lone pairs.
so I think B should be the right option, because there is one more group which is sp3 hybridized, means in between sp2 and sp3, but lone pair is more available due to SIR.
Yes.
And at the same time, releasing groups, it is also releasing.
Yes.
This one has minus I effect. There is no effect. So if we compare the order, it should be B, C, then A, and at last it is D. Right?
All right. Yes.
Which of the following compounds will not undergo the Finkelstein reaction with sodium iodide via SN2 reaction? So you know, any Finkelstein reaction, it is like this. We leads to the formation of iodide. So ultimately there should be a breaking of CBr bond,
Yes.
which is not possible in case of second due to double bond character. Again, it is not possible in third, same reason, due to resonance. So that means second and third, they will not undergo the Finkelstein reaction. So option A should be correct, right?
Yes.
In both cases, the reason is same, due to double bond character.
All right.
Which amongst the following are chiral compounds? In first case, you know, this carbon has hydrogen on one side, NH2 on the other side, but these two groups are same. So that means it is not chiral. In second case, on one side there is hydrogen and NH2, methyl and vinyl. That means it is chiral because this is chiral carbon, right?
Yes, sir.
All the groups attached are different. Here, this carbon attached to methyl, vinyl, but these are same.
Yes, sir.
Obviously, fourth should be OH,
Yes.
H. Positions are different because here it is methyl, this group, this is different, so that means this is again chiral. So that means second and fourth is the right. Okay, only A option is there. I think this question we have done.
Okay, the chiral center will be considered.
Just yes, find out the chiral centers. This is first chiral center, another chiral center, and there is this is called stereo center. This is not chiral center
Yes, yes.
because it will give geometrical isomer.
Okay, we'll get 8 products, sir.
Yes, we get 8 products because number of stereoisomers are 2 raised to power n. N is number of stereocenters. And this formula is applicable only when ends are different. There are different ends. On the one side there is a double bond, on the other side there is CH3CHOH. Okay, so total number of isomers are 8. Select the correct basicity for the following compounds. So start comparing. First of all, we compare it because all are nitrogens where there is a lone pair. First and foremost thing is we should see their hybridization. So in first case, what is the hybridization of nitrogen? In first case, it is sp3. Second case, sp2, and in this case, sp2 beta, because this lone pair is in conjugation with pi bond. Whenever lone pair is in conjugation with pi bond, lone pair is a part of pi electron cloud. Here it is again in conjugation. तो सीधे आ गया आपके पास कि फर्स्ट शुड बी मोस्ट बेसिक, because here lone pair is intact, lone pair is a non-sp3 hybridized carbon, so first should be most basic, and there is only one option where first is most basic. तो अगर ये क्वेश्चन आता है कंपटीशन में, तो there is no need to solve all the three, just see first one. Okay, but now just we are thinking about the options ki how do we get second on the second spot, and then fourth, and then third. So see, we have 2, 3 and 4. In all the cases hybridization is same. So now we go to the second step where lone pair is intact, that is in the second case. Here lone pair is not involved in conjugation at all. This lone pair remains intact, so that means this is more available for donation. Lone pair is more available for donation. So it should be first greater than second. Now come to third and fourth. So in third case, the group attached to the, yes, and more electron withdrawing group is attached, CO group. And you know, when there is a resonance, negative charge is on oxygen, and which is more feasible, more probable, so it should be more electron withdrawing. Okay, and in this case, in fourth case, this is a case of cross conjugation. Do you know what is cross conjugation? Cross conjugation means both the benzene ring tries to withdraw lone pair from the ring, from nitrogen. So at a time only one can get. So when this lone pair is given to this ring, so this ring will act as electron. It tries to withdraw electrons. So that's why lone pair is less involved in resonance, because it is not a extended conjugation. It is, this conjugation is crossing each other, because at a time only one ring can be involved in conjugation, but other ring will produce hindrance to the resonance. But it is just like SIR effect. Okay, that's why resonance is less. Here resonance is maximum. That's why third is least basic. Okay, that's all. So a nice effort, means questions are really good. So try to find out these type of questions so that we will enjoy the concept, means how do we apply, means it is which one is the last question? I don't know. If you can find out, you just send me now on WhatsApp. This okay. Okay. Send me only the one which is left. Okay.
The last one, sir.
Last one. Okay. Okay, this one?
Yes.
Okay. So see, in this case, you have this nitrogen with a lone pair. Another nitrogen has a lone pair. This one, okay. So see, least basic is which one? Least basic.
Second, sir.
Yes, but that will not serve the purpose, because in second is least basic in most of the cases. So that means we can reject D option by choosing this. Okay. Why is second is least? Yes, lone pair is involved in. And which one is the second means least?
Option 3, sir.
Option 3. Why?
Because of sigma lone pair group, sir.
Actually, see, in this case, there is only one lone pair, means one nitrogen which has lone pair and it is intact, right? But if in this case we show the conjugation, what happened? This nitrogen will get two lone pairs and with negative charge, and this means at a time one nitrogen remains intact, means the lone pair on nitrogen remains intact. And if we go on the other side, this lone pair again remains intact.
Yes.
But in this case, these two carbons are sp3 hybridized, and there is only one option of resonance.
Yes.
So first should be most basic, followed by third. Why is it so? Got it? Because this nitrogen will not decrease the electron density on the ring, on the nitrogen. It will increase the electron density. And in this case, even this part, that will increase the electron density, because they will show plus psi effect. So that's why it should be option C. First, third, fourth, and least is second. That you know, because this lone pair is a part of pi electron cloud, and that makes it aromatic. So that is least probable to donate. It cannot be donated. But more the number of nitrogens, and that will enhance the electron density on the other nitrogen. Means they're increasing the electron density. That's why first is more basic, followed by third, and then it is fourth. Got it? Okay. So that's all for today. जो भी क्वेश्चन कलेक्ट करके भेज देना, then we will have session. Okay. We have done aldehyde ketone carboxylic acid, ऑर्गेनिक पूरे हो गए. इनऑर्गेनिक ले लो, कोऑर्डिनेशन कंपाउंड्स, और डी एंड एफ कोऑर्डिनेशन कंपाउंड इकट्ठा ही रखो. ठीक है? ओके, श्योर. किसका करना है? ओके. तो which one? D and F or coordination? Oh, okay. So कौन सा आज कौन सा डे है? Thursday. Let's have class tomorrow for theory. Okay. D block, D and F. And then on the next day coordination, and then you will search for questions. In meantime, you find out the questions. Okay. Chalo, bye beta. Bye. Yes, I will send it. Well, I
Just technically selecting from four after.
okay.
તમે જે વ્યક્તિને કોલ કરી રહ્યા છો એ હાલમાં વ્યસ્ત છે